Hi, my name is Chuck. I'm a full stack software engineer. Today we are going to be building from scratch a message board application in node.js with Express. My hope is that by watching me build a complete web application from beginning to end, including authentication and tackling some issues that most web apps have to tackle, you can gain the broad strokes of how a web application is built and how to think about it, and provide some direction for your self-learning. This is a re-recording of a talk I've given several times, but most recently at Sunhacks in 2020. And let's jump in. So I'm going to get my terminal up. I always start a project in the terminal. And we're going to make a new folder. We'll call this web application video. Probably rename it. Let's go ahead and check it into source control immediately, because I always do. And let's get it open in our text editor. I use Visual Studio Code. I also like my sidebar on the right. So now for the important thing, we're going to spin up a new JavaScript project with npm. Before the video continues, if you haven't already, go ahead and pause and go and install node.js. Links in the description. I'm on Node, I think 12, because that's what we use at work. But any version of Node should work just fine. And also npm init does not normally take this long. That's interesting. Here we go. It's fine to just press enter a couple times. And here we go. Now if we tab back over to our Visual Studio Code, we'll notice a file has been created, package.json, which simply describes our package. And right now there's nothing interesting here, but there will be soon, because we're about to install some dependencies. But first, make a new file, call it gitignore, and add node modules. Okay, now that we've ignored our node modules folder, which is where JavaScript stores dependencies, we don't want to check those into Git because we're going to install them fresh on any new computer we use. Let's go ahead and do npm install express. So now our package.json now has a dependencies area that says express, and we have a node modules folder with a bunch of stuff. Don't commit that stuff to Git. Simply ignore it in Git, and then the next computer that you need to use your project on, you can run npm install with no arguments, and it will install everything listed in your dependencies. Okay, so what is Express? Well, let me show you. I made a new file named index.js. This is where we're going to put our code for now. Let's just spin up a basic web server. Semicolons in JavaScript are optional. You may or may not use them, up to you. All right, before I get any further in this, let's go ahead and run it. You can show and hide the integrated terminal in Visual Studio with control backtick. So we simply run node index.js. It should invoke and print listening on localhost 3000. Aha. So now if we go here in our browser, here we go. We get the text hello world. So let's talk through what's happening for just a brief moment. For more details and information, check out express.js's documentation. Google Express, and their website's the first link. This is true of all of the libraries I'm going to be using today. They're all well documented, and you should go look at their documentation for more information. But basically, Express is a web framework. What it does is it sets up a server that listens for requests from people's web browsers and responds to them with text. And request and response do actually mean something. All of the internet is built on top of a concept called requests. So when you visit a website in your browser makes a request to a server, and which server that is determined by the URL, the domain name that you typed in. It first looks up the address of the website you typed in, and then it makes a request to that website. And then that website responds with HTML and usually images and some styles and some other information. So every web server fundamentally does that thing, listens for requests and answers with responses. Express gives us a simple framework for setting up something similar. So app represents our web server. App.get/ hooks up a route on / and when you make a request, it always has a path. So you may have gone to website.com/whatever. /whatever is the path. In this case, when you're at the home page of a website, or the index, a couple different names for it, the path is represented with just plain /. That's a pretty common convention in most programming languages and tools. This app.get call is actually a function that takes 2 arguments. This whole thing is one function call. This first part is the path to listen on, and the second part is actually a whole other function that it will call for us when it receives a request at that /. So this function takes 2 arguments. It actually takes more, but we'll get there. Rec, which represents the request, and res, which represents the response. These are objects with properties and methods on them, and we'll get more into that later. In order to respond to a request, we call res.send. And in this case, we respond to / requests with the text hello world. Let's try hooking up another route. We'll do /time. And then the way you get the current time in JavaScript is you make a new date object, and then you call dot get time, or let's see if I remember this, locale time string. There it is. This will format it. If you called it in a web browser, this would format it in the user's local way of representing time. In our case, it's going to be running on our server, so it will always return the localized way to represent time for us, for me, for my computer. So let's go ahead, and I pressed Control-C to cancel the application. I'm going to run it again, node.index.js. Listening again, so I'm going to go back to, we've still got hello world on /, but now if I go to /time, the current time is 1:01:56, and that's true. However, you'll notice it's now 1:02 on my computer, and the time hasn't changed. That's because this website is just plain text. The browser made a request to my web server when I hit enter in the URL bar, and then the web server calculated the current time, put it in a string, and sent it right back, and there is no further interaction between the two. So the web app we're going to be building today will require reloading the page every time something changes. This is a traditional web application. This is how stuff like PHP works. Yeah, moving on. Let's begin hooking up actual web pages. But first, what is a web page? Well, when you go to a web page, you can actually see the code that makes up the web page on your computer with the developer tools. On Mac, it's Command-Alt-I. On other browsers and operating systems, it's different, although it is Command-Alt-I on Chrome on Mac as well. I don't remember what it is on Windows off the top of my head. If you go to your developer tools, there's usually a DOM or an inspector tab, and you can actually examine the code that makes up a web page. So you can see that the Google search box is actually many components composed together. So the question is, what is this? This is HTML. All the visual aspects of a website are represented by HTML. And we're going to need to generate HTML for our web application. However, we are not going to sit here and type out HTML inside of strings in JavaScript. That gets very messy very quickly. We're going to install a library to handle that for us. So we're going to be using a library called handlebars. And we're going to install it according to its own documentation. Copy the install command. Control-C to stop your application, and Command-V, or whatever your paste command is, to paste. And we're going to look through their docs while we're waiting. Just going to copy some code and paste it right in. Aha. So once we have this library installed, we now see that we will be replacing res.send with res.render and the name of a template. A template is just a snippet of HTML, and we'll get more into that a little bit later. Maybe. But for now, we're just going to do the example setup in Express handlebars. They want a views folder. They want home.handlebars. They want a layouts folder. And they want main.handlebars. And they even tell you what to put in them. So we'll just go ahead and paste that. And then we can put whatever we want in the home.handlebars. So I'm just going to go Hello World homepage. Alrighty. So now we're going to start our code again with node index.js. Our time page is still what it was before, but now our text is bold. And if we open our developer tools, which are also F12 in many browsers, didn't mention that, we can see that instead of just plain text, we've actually got some HTML code here now, including an H1. H1 in HTML means the most important header on the page. All the content on the web page is represented by tags, which are elements, and they might be paragraphs, boxes, images, that sort of thing. You break the page up into their smallest individual pieces. So here we've got this H1. Hello World homepage. And then we've got this other code, body, head, HTML. That's all in the main.handlebars. That's stuff that's going to be common to all or most of your pages, so we don't want to have to retype it every time. And that's the point of that system. So let's hook up a way to view messages. Our goal here today is to build a message board that takes messages from the user and stores them in a database. And the first thing we need to do is display messages. Arguably, the first thing to do is take messages, but for the sake of explanation, it'll be easier to explain how to show them and then take them. So that's what we're going to do. I'll make this smaller, make this bigger for now. Okay. First, I'm going to define an array of messages. In JavaScript, you can represent a string with single quotes or double quotes, and my preference for single quotes, because I'm lazy and I don't like holding shift, comes back to bite me when I have to use a backslash to escape the conjunction whose. Fun stuff. Let's add messages to our home.handlebars. We'll make a list. Li means
list item.
So what I'm writing right now is a mix of HTML. I screwed this up. A UL is an unordered list. Li is list item. What I'm writing right now is a mixture of HTML, this part's HTML, this part's HTML, and handlebars. This is handlebars, and this is handlebars. For more information on handlebars, go to their documentation. And HTML, there's tutorials all over the internet. But basically what I'm doing is for each message inside of messages, we're going to copy-paste the same bit of code for that message. And that code is just an li, and then the contents of the message, and then a /li, which is called a closing tag. Most tags require an opening, some content, and a closing. There are exceptions, and we'll get to those. We'll hit save. And then we just need to pass the messages in. Oh. For now, you should simply accept that this is how you pass variables from the JavaScript into the template. The res.render is a function that takes two arguments. The first is the name of the template. The second is an object containing the variables that it should expose inside the template. So this, in JavaScript, is how you can make objects in line. You don't need a class or anything if you're coming from an object-oriented language. And this is actually shorthand. It might be a little bit easier to see if I show you the sort of longer form. In JavaScript, objects are just a bundle of variables all tied together. They're key value pairs. You have the name and then the value of everything in that object, and you simply define them with name, value. In cases where the name is the same as the variable that's already in scope, you can simply do that, and that is equivalent. I'm going to set this back for legibility. Okay, let's start our application over again. Refresh the page. So now we'll see we have a bulleted list. Let me move my developer tools to the bottom. Now you can see we have a bulleted list of messages. Hello world, is anybody out there? Who's there? These are the messages that we define in JavaScript, and then we passed into our home template over here, and then in our home template we render each of them. We had style equals font style italic. If we add this to each of these and then we refresh the page, they'll all become italic. And if, just to demonstrate how each works, this is always there. Now I've added another li to this ul. I've added another list item to this unordered list, unordered meaning bulleted as opposed to numbered. And now there's a non-italic one at the top of the list at all times, even though there's no message in our code that says this is always there. So the glue that makes the messages from the code appear on the web page is this right here. This iterates over every message and prints essentially this bit of code for each one. And you can see inside the UL we have several LIs. And these ones all have the font style italic. So the next question is, of course, how do we collect messages from the user? Well, to do that, we use forms. So let's write a form really quickly. And I promise I will go over this in a moment. I'll make this a little more explicit. Send. Okay, so a form element is a group of inputs and buttons that when you submit the form will send some information back to the server. How it sends the information and where it sends the information is defined up here. And what information it sends is determined by the contents of your inputs. So earlier we talked about requests and responses. Requests have different types. There are different types of requests. When you type a website into your address bar and hit enter, your browser sends a GET request, which is meant to retrieve information, but there are more. When you want to send info to an application, like with a form, usually you use a POST request. And the cool thing about a POST request is it also has a body. So we can send information as part of the request without placing it in the URL, which is how GET requests would work. There are other types of requests. There's PUT, which is meant for modifying existing resources, and there's delete, which is meant for deleting things. But browsers can only make GET and POST requests. If you make a form with method equals GET, it will put the contents of your inputs in the URL itself and then redirect the user. Which we don't want. We don't need this to show up in the URL. So with a POST request, it'll still redirect the user, but it won't expose our form data to them. So we're going to do that. The other thing is, when you're putting labels on inputs, generally you want to use the label tag, and then use the for attribute, and match that to the ID attribute of the input it's associated with. Among other things, that allows you to click on the label in order to focus the input itself, which is nice for things like checkboxes, but it also makes life easier for people that use screen readers. So highly recommend doing that. The other stuff about input, there are a number of different types of inputs. There are inputs like email and date, which on phones will show different styles of keyboards in order to make input more convenient. So if you're collecting an email, make sure to use the email input. If you're collecting a date, probably use the date input, but there are problems with it, etc. In this case, we want a text input because we're collecting text. Then there's a button. Button type equals submit will cause the form to become submitted. The only other thing is I mentioned before that a form element, when submitted, will send information to a given location with a given method with a request. The action attribute says where to send the form request. So this will send a request to /message. So we need to hook that up. So we're going to listen for a post request on /message, app.post /message res. And we have one more bit of setup we can do before we can actually read the contents of the request. We have to use a body parser. I don't know why Visual Studio does that sometimes. This is just something you'll find in Express's documentation. For a number of reasons, Express does not parse request bodies automatically, and in order to do so, you have to hook up what's called a middleware. And we'll get more into middleware later, but for now, simply know that this is the URL encoded body parser middleware. So URL encoding is how browser forms work by default. There are other ways of encoding bodies of requests, but we won't get into those now. Just know the most common other one is JSON. And you'll see that if you work in React world or with like mobile apps and that sort of thing. Okay. What I'm going to do here is I'm going to grab the message text from the body. Request.body is made available by the URL encoded middleware. And it's under the field message text. The names of these fields are determined by the name attributes on the form in your HTML. So the input is named message text. So when the request comes in from the browser, the field with that input in it will be called message text. That's the association there. Messages is an array, so we can call .push to add new things to it, message text, and then we can redirect the user to the home page. So when we redirect them, we will return with a response to the browser that says, hey, you just navigated to /message, navigate back to /. So it will. And then when it gets to /, it'll make a new request to /, and when it does so, we will render home, meaning we will take the home template, combine it with the main template, turn that into HTML, and then send it on back as text. So let's watch that happen in action. We're going to need to stop and restart our code because we touched the JavaScript file. We'll refresh the page. Hello world. I'm going to hit send. And there it is. It appeared. We never saw anything. We never saw anything on the message page because we never render anything. In fact, the redirect is so fast we don't even see the URL bar change, but the entire page is reloading. Hopefully that makes sense. If not, it's kind of just something you need to get used to, thinking about requests and responses. What I can do is I can show you that the URL changes by not redirecting. I'm going to stop and start the code again. Now, by responding to the request instead of simply redirecting, will cause the user's browser to remain in /message after they send a message. So let's watch that work. Message received test. So you can see we're now at localhost 8000/message. And another thing, if you've ever seen a warning from your browser that says they must send information that will repeat any action that was performed earlier, I think Chrome says we'll have to send a request again, that sort of thing. What they're telling you is that you got to this page via a post request, and we're going to post the information again. And for something like a Facebook post, or in our case, a message post, it would cause that message to be posted twice. So I'm going to hit resend, and then I'm going to go back to the home page. And if I refresh the page, you see there's actually 2 test messages here. There's also no new messages because we cleared out those new messages we added every time we restart the code. The messages array gets reset to this. So let me show you this 2 more times. So I'm going to hit send, message received. I'm going to refresh and hit yes. And now when I go back, there are 2 messages, even though I only hit send once. So just a fun fact, that's what that warning means in browsers. But, of course, we don't want users to have to go hit back. We want to just redirect them. So now, what's going to happen is when they submit a message, we're going to save that message to the array, and then we're going to redirect them to the home page, and then the home page is going to show them the messages. And then we need to restart our code in order for that to happen. One last time, shall we? Test message, just to make it clear it's different. Here we go. Our message board is working. Sounds like a good time to commit. All right, that's the end of part one. In part two, we are going to introduce adding a database.